IGCSE Weather, Climate, and Ecosystems. So we're going to split up this section into 3 parts because it's really long. So we'll have 3 different little videos. So firstly, some definitions. Weather is the current state of the atmosphere in regards to temperature, cloud cover, wind speed and direction, precipitation, and humidity. So weather is what's right now or in the next few days. But the climate, it's the average, so kind of the general normal weather conditions that a region or country experiences. So climate is averaged over a number of years. For instance, we would say that the climate in, the Antarctica is very cold and, freezing, whereas the weather could change from day to day. For instance, one day it'll be super sunny, the other day it'll be really windy, you know what I'm saying. There is a difference between weather and climate. Weather is daily and climate is the general average over a number of years. So, when we measure weather, we use certain equipments. Firstly, a STEVENSON screen. So it's basically a white louvered box, and louvered, this word means that it has these little wedges kind of thingy, like your blinds do in your house, in front of the windows. So the box, it's designed to contain some weather equipment, like the thermometer and barometer. So the STEVENSON screen, it's okay, because it might, on a question, ask you why is it how it is, so tell us why it's designed this way. Well, you will say that it's white so that it can reflect sunlight. Okay? So that's the first kind of characteristic of it. It's white so it can reflect sunlight, and it has slats, so again, these thingies, to allow air to circulate easily, so that the air can come in and stuff, and for the thermometers and stuff to work. So the STEVENSON screen should be placed above the ground and away from the buildings. The idea is for the weather instruments to take accurate readings of the air, rather than direct sunlight or heat from the ground or from buildings. So for more detailed information about the sighting of a STEVENSON screen, So the location of a STEVENSON screen in more detail. Well, basically, recap, it's a small weather station that is used to measure local weather conditions. A weather center will include a thermometer, so the maximum minimum, a hygrometer, which is a wet-dry bulb thermometer, we'll go over these in a second, and a barometer. Outside the STEVENSON screen, there will be a rain gauge, an anemometer, and a wind vane. So, why is it designed like it is? Well, firstly, it's painted white so that it can reflect incoming solar radiation, so it can reflect light. It does not want to absorb heat because if it does, it won't give an accurate reading of the air. Also, it has a height above the ground, so as you can see, it's placed on stilts. It's not on the floor. Why is this? Well, it should be above the ground, at least 1.2 meters, so that it does not receive heat released from the ground, because that would influence the measurements. Also, it has a roof to protect the instrument from precipitation, which is rain, because rain could affect temperature or humidity readings. Also, as you can see, it's in an open field, so it's away from buildings. This is to avoid any heat from buildings or any shadows from buildings, and the STEVENSON screen should therefore be placed away from them. And the door of the screen should always face away from the sun. This means that in the northern hemisphere it should face north. And the screen has slats, like we said before, to allow air to circulate freely around the instruments, so the air can go in and go out. It's also in the open. It should not only be away from buildings, but also from trees and hills. This will ensure that air is allowed to circulate and that the screen is not in the shade. The screen should be twice the distance away from an object as the object's height. For instance, if a tree is 10 meters, then it should be 20 meters away. Also, you can see that it's on grass. To avoid reflection from white surfaces or absorption from dark surfaces, STEVENSON screens are usually placed on grass. So a barometer. Barometers are used to measure air pressure. And it's measured in millibars. Just think of barometer millibars. So barometers are normally kept inside STEVENSON screens to keep them safe, because you can see they're pretty fragile, sensitive. And a barometer has a movable needle, so a pointer here. And the pointer can be moved to the current reading so that you can then make a comparison with the reading from the following day. Okay, so a maximum and minimum thermometer, sometimes called the sixest thermometer because the guy who invented it was called Mr. Six. Okay, so basically a maximum and minimum thermometer records the maximum temperature of the day and the minimum temperature of the day. So you can use it to find the diurnal range, which means daily range of temperatures. So a maximum minimum thermometer contains a mixture of mercury and alcohol. The mercury sits in the U-bend, so here, of the thermometer. The bulb at the top of the tube reading the minimum thermometer, reading the minimum temperature contains alcohol, and the bulb at the top of the tube reading the maximum temperature contains a vacuum. On the minimum side, the expansion of the mercury is restricted by the contracting alcohol, and on the maximum side, the expanding mercury can expand more freely into the vacuum. At any given time, both thermometers should record the same temperature. However, during the day, they would have recorded the maximum and minimum temperatures, and a steel marker should indicate these temperatures. So, a wet and dry bulb thermometer. A hygrometer, which is another word for wet and dry bulb thermometer, measures the humidity of the air. Wet and dry, it's pretty straightforward. Because humidity is the amount of moisture, so water vapor, in the air. A hygrometer has two thermometers, a dry one and a wet one. Humidity is measured by using a table that looks at the difference between the wet bulb and the dry bulb. A hygrometer can also be used to find dew point. There is a difference between the dry and wet bulb thermometers because of latent heat created during the process of evaporation. So, anemometer. These measure wind speed. So as you can see, there are these little cups, and they turn around and it measures the wind speed. So, and it's normally measured in miles per hour or kilometers per hour, but can also be measured in meters per second. Digital anemometers, and then anemometers are very, very accurate, but the more basic plastic ones that many schools have aren't very good nor accurate at reading light winds. And anemometers, I can't even pronounce it, are normally placed on top of buildings so that they're not protected from the wind and so they don't experience channeling of wind. For instance, if an anemometer was placed in a corridor where wind was forced through, the readings would be higher than normal. Okay. Then we've got a wind vane. Wind vanes are used to check the direction of the wind. Compass points are used to give the direction that the wind is coming from, so we can see north, east, south, and west. And wind vanes are often placed on top of buildings so that they're fully exposed to the wind. When using a wind vane, you do need to use a compass to make sure that it's properly aligned. Okay, now we've got the rain gauge. Rain gauges are used to measure rainfall, and it's measured in millimeters. Rain gauges should be placed on grass, because if they're placed on concrete, extra water can splash into them, because it's a hard surface and would therefore, make the water splash. Rain gauges should also be checked regularly to avoid evaporation. So how you would do it, you would dig a little hole in the earth, in soil, you put it in an open grass field, you would dig a hole, then you would put in this inside, and this is for the outside. Okay, so this is under earth. And then as the rain goes in the day, you take it out and you would say, if the water fills up to here, you would say 30 millimeters of rain. So, okay, climate graphs. Climate graphs show the average temperature and rainfall for a city or region over the year. Temperature is always shown in the form of a line graph. Some climate graphs have the average maximum temperature and the average minimum, whereas others just have the overall average temperature. The line graph is normally colored in red. Rainfall is always shown in the form of a bar graph and normally colored in blue. So all these bars, that's the rainfall, and the temperature are the lines, okay? Yeah. Climate graphs are very, very good for showing averages, but they don't show anomalous years because it is based on averages and doesn't show things like the number of days of rain. A month may have 50 millimeters of rain, but we don't know that that comes in small rain showers or one big thunderstorm. When reading climate graphs, you should look for trends and anomalies. On the graph below, the temperature trend is fairly easy to read. It increases from January to July, then decreases until December. The rainfall data is not as straightforward because some of the early months fluctuate, so they go up and down. Whenever you are describing graphs, remember it is very, very important to use figures with the correct unit. Occasionally, you may be asked to give the temperature or rainfall range. This is the difference between the highest and lowest total. Clouds. Clouds are a collection of water droplets or ice crystals. The warmer the air temperature, the more water vapor the air can hold, okay? If it's warmer, the air can hold more water vapor. However, when the air starts to cool, water vapor starts to condense, as long as it has condensation nuclei to condense around. Okay, cirrus clouds. They're these little thingies up here. They're found very, very high up in the atmosphere, usually 5,500 meters or 5.5 kilometers up, okay? They're very up high at the very top. And they're common throughout the world. They're thin and wispy in their appearance, and they move fairly quickly. The stratus clouds, right here, they're low level. They're below 2 kilometers or 2,000 meters high, and they sometimes reach the ground. And they're usually gray and in color, and they move pretty fast, and they can produce light rain and snow. Then cumulonimbus, which is this huge thing. They are large clouds up to 10 kilometers high and across. They resemble giant cauliflowers. They resemble giant cauliflowers, kind of thing. And they produce rain, thunder, and lightning. They're usually found in the spring and in the summer. Then you've got the cumulus. They're fairly low clouds with bottom between 600 meters and 1,200 meters. And they look like lumps of cotton wool, and they can produce light rain. And individual clouds have a short life cycle. Okay, temperature. There are many factors that can impact temperature. The most common causes are the ones listed below. Firstly, latitude. Places in the tropics, so places between the Tropic of Cancer and the Tropic of Capricorn, are much, much warmer than places furthest away near the poles. This is because the sun is more overhead in areas near to the equator. So, distance from the sea. The sea takes longer to warm than land, so places near the sea are cooler in the summer because the sea cools them. However, the sea retains the heat better than the land, so places near the sea are warmer in the winter because the sea warms them. Prevailing winds. If the prevailing wind is from the poles, then the temperature will be lower, but if the prevailing wind is from the tropics, then the temperature will be higher. Ocean currents. Ocean currents are classified as hot or cold. Hot ocean currents tend to warm winters and cold ones cool summers. The UK benefits from a warm ocean current traveling from the Gulf of Mexico, so it does make it a bit warmer in the winter. Okay, altitude. Temperatures on average decrease 1 degree Celsius for every 100 meters gained. This means that some places near the equator, so for instance the Andes in Ecuador, can be covered in snow all year just because of how high up they are. Aspect. This is the direction that something faces. For example, in the northern hemisphere, the south-facing slopes face the sun, and north-facing face away from the sun. This means that in the northern hemisphere, south-facing slopes are warmer and ideal for growing things like grapes and olives. So, precipitation. This is rainfall. Precipitation is any moisture that falls from the atmosphere. The most common types of precipitation are rain, snow, sleet, hail, fog, and dew. Clouds basically form when water vapor, so moisture, in the atmosphere starts to condense into water droplets. Water vapor starts to condense when the atmosphere can hold no more water, so when it's saturated. Warm air can hold more moisture than cold air, so when air starts to cool, water vapor is more likely to condense. Therefore, the formation of clouds and rain is most likely to happen when air cools. The three main types of rainfall are frontal, relief, and convectional. However, it is important to note that water vapor must have condensation nuclei to condense around. So what's a condensation nuclei? Well, it's basically a surface that water vapor can condense on. This might be a piece of dust or a tiny grain of sand. So, there are three types of rainfall. Firstly, frontal, relief, and convectional. So let's look at frontal rainfall. This happens when an area of cold air and an area of warm air meet. The warm is less dense, right? So it's forced over the top of the cold air. As the warm air rises, it starts to cool. And as it cools, it can hold less moisture, so the water vapor starts to condense. The condensing water creates clouds and rainfall, okay? So here you've got warm air and here you've got cold air. Well, when they meet, the warm air rises, then, it cools. So as it cools, it can hold less water vapor, so the water vapor starts to condense, and the condensing water creates clouds and rainfall. So that's frontal rainfall. Think of it, they're going right at the front of each other. They're fronting. Then we've got relief rainfall. This happens when air runs into a mountain or a hill. And as the air meets the higher land, it is obviously forced upwards. As it is forced up, the air begins to cool, reducing the amount of moisture that the air can hold, and causing the water vapor to condense, creating clouds and rainfall. So relief, we all know relief is like the land, if it's flat or not. So you would say that this one has relief, so because it's a mountain. So the air from the sea blows the air, right? Then the warm, moist air from the sea is forced to rise, since there's this object here, this hill, that it forces it to go up. So when it goes up, it cools, so the water vapor will condense to form clouds and then to rain. So then what you have here on the other side is something called a rain shadow area, which we'll go over after. So just keep in your mind, in relief rainfall, there is a rain shadow area formed. So, and convectional rainfall. This happens when the ground warms the air above it. So as the air above the surface warms, it becomes light and starts to rise. As it rises, it starts to cool, and as it cools, it can hold less moisture and the water vapor begins to condense, creating clouds and rain. Convectional rainfall is very, very common in tropical countries and is more likely to happen in the afternoon once the air has had a chance to warm, rise, and condense. So basically, sea pushes in air, and then here the ground warms the air, okay? Because it's a hot day, so the sun makes the earth absorb heat, and then the heat from the earth heats the air, so then the air rises, and then the water vapor condenses, and then there's rain and clouds. So back to rain shadow. Well, the rain shadow is a dry area found on the lee side of mountains. A rain shadow gets below average rainfall because all the rain is deposited on the top of the hills, mountains. So, air, pressure, and wind. Air pressure is simply the weight of air pressing down onto the surface of the earth. When air is warm, it normally rises and creates an area of low pressure. When it's cool, it sinks and creates an area of high pressure. Pressure is measured on a barometer. It is usually measured in millibars, and areas of the same pressure are joined together on a map, but you don't need to know this. Okay, air rises through the process of convection. It moves horizontally through the process of advection and sinks through the process of subsidence, but you don't need to know this. You just need to know the principle of convection, that when it's hot it rises, and then it cools, and then it goes back down. Okay, wind is created by air moving from areas of high pressure to areas of low pressure. This can happen on a local scale or on a global scale. So global winds can create cells. The three main cells are the Hadley, Ferrel, and Polar cells, but you don't need to know that in so much detail, but fairly some. So all the cells operate very similarly, so I will just talk about the Hadley one, okay? The Hadley cell. Because of the hot temperatures near the equator, the land warms the air above, which begins to rise. And as it rises, it is pushed out towards the tropics, where it begins to cool slowly and sink. The sinking air then returns towards the equator, where there is low pressure. And the rising air causes a convectional rain near the equator. However, because of the rain over the equator, the air reaching the tropics is very dry, creating arid desert-like conditions. So, the intertropical convergence zone. This is the sometimes referred to as the ITCZ. So, it's an area near the equator where winds meet from the northern and southern hemisphere. Okay? So, where they meet, there is a very little wind. However, even though there are limited winds, it does have violent thunderstorms on occasions.